definite integral using u substitution with the change of limits or interval. So let us first define what is definite integral. So definite integral refers to be the limit and summation of the net area between a function and the axis. So we have here the notation for definite integral. Here, the a represents the lower limits which makes the b here the higher limit. So here is the notation for the definite integral, and let us now proceed to our first example using the u substitution with the change of limits or interval. So we have here the interval of 2x, x squared plus 4 squared dx, with the upper limit of 2 and the lower limit of 0. So let us now proceed and define what is the value of u. So u is equals to x squared plus 4. Du is equals to 2x, which represents the dx, 2x dx, du over 2x is equals to dx. So before we evaluate this equation, we need to change the upper limits 2 and the lower limits 0 using u substitution. So let us now proceed first to the lower limit, which is the 0. So f of a or u is equals to x squared plus 4 equals to x, which represents the lower limit 0, 0 squared plus 4 copy is equals to 0 squared is equals to 0 plus 4. 0 plus 4 is equals to 4. So 4 is now the new change value of our lower limit, and for the for the upper limit, which is f of b or u x squared plus 4. So the value of our upper limit is 2, which is 2 squared plus 4 equals 2 squared is equals to 4 plus 4. So 4 plus 4 is equals to 8. Now 8 is the new value of our upper limit. So f of a is equals to 4 and f of b is equals to 8. So let us now proceed to our evaluation. So for our evaluation, we will use the power rule. And that would be u squared du. So we have here the upper limit, which is the 8, and the lower limit 4 equals to u cubed over 3. So in order to get the final value or the final area for the definite integral, we have to substitute the u with the limits, upper limit 8 and 4. So a substitute to u, which makes it 8 cubed over 3 minus the 4 substitute to u, 4 cubed over 3. So now we will calculate 8 cubed, and the answer is 512 over 3 minus 4 cubed is equals to 64 over 3. So to get the final answer, we have to subtract 512 to 64. And so the answer will be 448 over 3. So 448 over 3 now is our final area for definite integral. integral using u substitution with the change limits or interval. So let us now proceed to our second example. So our second example is so we have here the interval of 2x, x squared plus 5 squared dx with the upper limit of 4 and the lower limit of 3. So first, we have to find the value of u. So u is equals to x squared plus 5. So du equals to the value of dx, which is 2x dx. Du over 2x is equals to dx. And now let us proceed to the lower limit. So f of a or u is equals to x is substitute to the lower limit, which is the 3 squared plus 5 is equals to, so 3 squared is equals to 9 plus 5. So 9 plus 5 is equals to 14. So 14 here is the new change value of our lower limit. So f of a equals to 14. Now for the upper limit, u is equals to upper limit, which is the 4 squared plus 5. So 4 squared is equals to 16. 16 plus 5. So 16 plus 5 is equals to 21. So 21 here is our new change value for the upper limit. So now, let us proceed for our evaluation. For our evaluation, we will use the power rule. Which is u squared du. So we have here the upper limit 21. And the lower limit is 14 equals to u cubed over 3. So, to find the final answer or the final area for definite integral, we will substitute u with the upper limit 21 and the lower limit 14. So, 21 substitute to u. 21 cubed over 3 minus 14 cubed over 13. So we will calculate 21 cubed and the answer is 9,261 over 3 minus 14 cubed is equals to 2,744 over 3. So to get the final answer, we will subtract 9,261 to 2,744. And the answer is 6,570 over 3. So 6,517 here is our final value for the definite integral using u substitution with a change of limits or interval. So that is the end of my discussion. Thank you and God bless us all.